Let's be honest. Most people study math the same way they scroll through social media. They open a massive textbook to a chapter titled Algebra, look at 100 different symbols, feel an immediate sense of dread, and then wonder why they don't get it. The secret to actually mastering math isn't about being a genius. It's about shrinking the target. If you try to learn all of algebra in a night, you'll learn nothing. But if you spend that night mastering just one narrow slice, you become dangerous. I'm talking about moving away from broad topics like quadratics and zooming in on something like factoring trinomials where a equals 1. Think of it like this. You wouldn't try to learn an entire language in a weekend, but you could learn how to order a coffee and ask for the bathroom. In math, specificity is your best friend. When the topic is small, the logic is clear. So before you even pick up a pencil, pick your niche. Don't just study exponents, study the quotient rule for exponents. Master that one specific tool, and the rest of the toolbox starts to make a lot more sense. Once you've picked your narrow topic, you need to understand the why behind it, not just the how. And that's where most people trip up. All right, you've got your topic. Let's say it's the quotient rule for exponents. Most textbooks will just throw a formula at you, like x to the power of a divided by x to the power of b equals x to the power of a minus b, and tell you to get to work. But here's the thing. If you just memorize that string of letters, it's going to leak out of your brain the second you get stressed during a test. To make it stick, you need to understand 3 things, and you need to do it in under 2 minutes. First, the rule. It's the shortcut. In this case, when you divide powers with the same base, you subtract the exponents. Simple. Second, the why. This is where the magic happens. Why do we subtract? Well, if you have x to the power of 5 divided by x to the power of 3, that's just 5 x's on top being divided by 3 x's on the bottom. 3 of them cancel out, leaving you with 2. 5 minus 3 equals 2. Suddenly, the rule isn't some arbitrary law. It's just common sense written in shorthand. Third, the when. You use this only when the bases are identical. You can't use it on x to the power of 5 divided by y to the power of 3. They have to be family. Don't spend an hour here. Get the aha moment, realize the logic is sound, and then move on. You don't need to be able to derive the theory of relativity. You just need to know why the tool in your hand actually turns the screw. Because once you see the logic, you stop studying and start knowing. But knowing isn't doing, and that's where the examples come in. Now, you're going to look at 2 or 3 solved examples, not 10, just a few. You aren't just reading them, you're performing an autopsy on them. When you see a step taken, don't just nod and say, okay, I get it. Stop. Ask yourself, why did they choose this specific step right now? If the problem is 12x to the power of 7 divided by 3x to the power of 2, and the first step is dividing 12 by 3 to get 4, ask yourself why they didn't subtract 12 and 3. The answer? Because the coefficients are regular numbers, not exponents. Try to stay one move ahead of the person solving it. Before they write the next line, try to predict what it will be. If you get it right, you're starting to see the pattern. If you get it wrong, that's actually better, because now you found a gap in your logic before it costs you points on a test. Don't just let the solution wash over you. If you can't explain why a step happened, you haven't actually learned the step. You've just witnessed it. Once you've predicted your way through 3 examples, it's time to take the training wheels off. All right, the training wheels are officially off. This is where the real work happens. You're going to solve problems, and you're going to solve a lot of them. This step should take up about 70% of your total study time. But you aren't just grabbing random problems, you're going to follow a specific path, the climb. First, the easy problems. Don't roll your eyes at these. These are for building muscle memory. You want to reach a point where you see x to the power of 10 divided by x to the power of 2, and you don't even have to think. Your hand just writes x to the 8th. You're building familiarity here. Next, the medium problems. This is where the understanding we talked about earlier gets tested. Maybe the exponents are negative, or maybe there are fractions involved. These force you to apply the rule in a context that isn't perfectly straightforward. Finally, the hard problems. These are the mastery level. These problems will combine 2 or 3 different rules at once. They're designed to trip you up, to hide the rule inside a mess of other numbers. If you get stuck, don't immediately run back to the solution. Wrestle with it for a minute. The struggle is actually where the learning happens. But when you inevitably get one wrong, and you will, don't just erase it. That mistake is a map of exactly what you don't know yet. To fix it, you need to categorize it. Every math error falls into 3 buckets. Bucket 1, the concept error. This is the big one. This means you didn't actually understand the rule. You tried to subtract exponents when the bases were different, or you added them instead of subtracting. If this happens, you need to go back to step 2. Your why is broken. Bucket 2, the application error. You knew the rule, you knew why it worked, but you got lost in the middle of the problem. Maybe you forgot how to handle a negative number, or you didn't see how the rule applied to a fraction. You have the tool, you just don't know how to swing the hammer yet. Bucket 3, the careless error. These are the most annoying. You knew exactly what to do, but you wrote 5 minus 3 equals 8, or you missed a minus sign. We all do it, but identifying it as careless tells you that you don't need to restudy the math. You just need to slow down and check your work. Understanding why you were wrong is the only way to ensure you're not wrong the next time. But just identifying the mistake isn't enough to fix it. You have to prove you can do it right. Once you've analyzed your mistake and you think you understand where you went wrong, close the solution, hide the correct answer. Now, take a blank piece of paper and solve that exact same problem again from scratch. Why? Because there's a massive gap between recognizing a solution and generating one. When you look at a correct answer, your brain tricks you into thinking you could have done it yourself. It's called the fluency illusion. By resolving it immediately, you're forcing your brain to actually build the neural pathway for the correct method. You're locking the logic into your long-term memory. If you get it right, great, move on. If you get it wrong again, that's a signal that you still haven't fully grasped the concept. Go back, look at the error, and try again. Don't leave that problem until you can do it perfectly on a clean sheet of paper. That's how you turn a mistake into a permanent skill. Stop reading math, start doing math. Pick your topic, find your why, climb the difficulty ladder, and never let a mistake go to waste.